Ladies and gentlemen, I guess that we can start the official opening of this conference. Welcome at the conference organized by the National Science Center in Poland. My name is Angelika Muchowska, and it is a great pleasure to be a host of today's conference. The conference is organized at a very amazing place here in Olivia Business Center with a spectacular view that you have seen at the beginning when you came to this room. I'm happy to welcome also viewers that joined the conference online, and I hope you will enjoy it as much as people, as guests that are here in studio. We have met today to promote the basic research program carried under the third edition of the EEA and Norway grants, and I will invite here on this scene a guest that will share further information and details about this program and today's conference. With a great pleasure, I would like to welcome Deputy Director of the National Science Center in Poland, Mr. Marcin Liana.
Thank you very much. It's my real pleasure to welcome you here, distinguished guests, distinguished speakers. Today, during today's conference, we'll hear the presentation presenting the results of the projects conducted and financed by National Science Center under the Norway Fund scheme. National Science Center is the Polish grant agency set up in 2011 to fund basic science in Poland. We have different programs for all disciplines of science. We fund art and humanities. We also fund psychology proposals, life sciences, engineering, and other disciplines of science. We also have funding schemes for scientists at each career stage. And also we are the operator of the Norway funds in the third edition. Our partner from Norway is the Research Council of Norway. Under this funding scheme, we set up different programs. The biggest one is the Greek program for joint research between Polish and Norway scientists. This is our biggest program. We fund 35 proposals, and actually we spent the major part of the funds on this program. This is almost 37 million euros. The second one is the Idea Lab. We fund only a few proposals under this funding scheme, but these are very innovative and interdisciplinary proposals. And we also have the POLS funding scheme for the scientists incoming to Poland to conduct their research here in Polish scientific institutions. During today's meeting, we will hear the presentations in two very important topics that are the priorities of the spending of this money, which is the climate change and polar studies. We will have the presentation about these very important topics that have the impact of the life on Earth right now. We realize that this is very important for all of us, and I hope that today's meeting will be very interesting for all of us. Thank you.
I guess we all think that it will be a very interesting event. And now I would like to ask for welcoming words from Sławomir Sagan, Deputy Director of the Institute of Oceanology in Polish Academy of Science.
Ladies and gentlemen, with a great pleasure, and I'm here, and I will take the opportunity to present some information about the institute, which is a beneficiary of Norway grants for years. Institute of Oceanology, as you can see, located in Sopot, very close to the area of the research here, seen on a background of what might be cyanobacteria bloom and suspensions in the water which can be observed and controlled remotely. Institute is also very conveniently located on a seashore of the Gdańsk Bay, and we take advantage of that location. Maybe except of the summertime when the noise from the beach sometimes distract guys from concentration of their work. And general mission of the institute is centered around basic research, and that's from the start. That's from the very start of the institute. That was the idea of establishing the institute. And those strategic, this mission is accomplished through the defined strategic directions of the research of IOPAN, and area of our activity. The first is natural, is the Baltic, but about half of resources we deployed in European Arctic, and especially Spitsbergen, Svalbard area, and recently also Greenland. And that's the consequence of years of collaboration with the Norwegian Institute, well before the Norway grants were launched. But mainly that close cooperation with Norwegian partners brought us closely to Norwegian grants, and we, from the very start of the program, we took the opportunity to use that funds for the research. The institute consists of six departments, and basically we covered all the areas of the oceanography needed for full knowledge of the process of the ocean. So to very much extent we use our own expertise. There's a close cooperation between the departments. Sorry. That activity would not be possible without our main research platform, which is vessel Oceania, launched in 1986. So as you can see, it's a pretty old vessel. It's actually that's no more than 10 years ahead of us with it, and we are try hard together with the scientific community in Poland to acquire a new vessel which will serve all the oceanography community in Poland. Institute's international cooperation, it's on a 3 or 4 pillar: science policy, research network, and ocean observations. We are partners on members of European Marine Board, that's the science policy body, closely cooperating with DG Research of European Commission, and also Intergovernmental Oceanographic Commission of United Nations. There's a part we are active in activities on operational oceanography and observational aspects, and especially EuroArgo. That's a global program of floats, currently about 4,000 around the globe, and we are active in that area, and Poland finance part of this effort. Several floats. Each cost about 40,000-60,000 euro. It's financed by Polish government, the ministry, and we are operators of those small of those fleets. A part of statutory funding we received from the ministry. The huge, more or less half of our budget is from projects through funding programs. And as you can see, the first from the top, that's an example from the last year. More than 50 projects that were of a profile of pure basic research funded by National Science Center and Horizon Europe. Smaller portion has more application slant of activity. And within that, we have currently we run 4 projects funded by Norway grants, but from 2008 we've got 13 already, and that's produced us quite a lot of good science. And at the end, what we have started from, I think it's a good example of a problem for the basic research, which has very short way for a solution of the application side. That's an example of a cyanobacteria bloom in the Baltic Sea, observed from the satellite. And despite we know very well what are conditions needed to set off the bloom, right temperature, nutrients level, light, we still don't know what's actually triggered that bloom. And so it means not all processes are known. So the basic research is really of essence in that aspect, and in many aspects, other aspects as well. But once that would be solved, it will bring us a solution, very practical solution. There's huge demand from the application side of that knowledge. So there's close link between basic science and application side, but without that first, we will stop. Thank you very much for that, for your attention, and thank you very much for organizers for giving me opportunity to present our institute, and I hope for the very interesting conference, and we invite everybody tomorrow for the part at the institute, and then on the vessel Oceania. Thank you very much.
And we thank you for sharing this some informations and activities that Institute of Oceanology is heading for. And now I would like to ask Alexandra Witczak-Haugstad, Research Council of Norway, to say a few words.
Good morning, and thank you very much. So, on behalf of the Research Council of Norway, it's really a pleasure to be at this conference, to see the program, and not least the participants. Thank you very much to the National Science Center for organizing this. We're really pleased to be here. EA and Norway grants provide opportunities for cooperation in research and in other areas, but these opportunities need to be grabbed by somebody. We need ideas and proposals for cooperations, and we want to see interesting cooperations. So with polar research, ocean research and climate research. Those are really very central priorities for Norway and kind of for the Norwegian government and for our country. So it's a pleasure to see this great interest and a lot of projects in this area. I would also like to say on behalf of my organization that in our experience, the polar research community is a very strong, reliable partner for Norway in polar research. And in these turbulent times, more than ever, we do need reliable and trusted partners. As mentioned in the first already, RCN, Research Council of Norway, we act as donor program partner in this program. So we have an advisory role. We have a lot of contact with NCN, and we really enjoy this cooperation. We also act as contact point for the Norwegian institutions that are involved, but we're very much also interested in hearing from all of you. So do talk to us. I have a colleague with me here, Sophia, as well from the Polar Department, and we'd like to talk to you during the coffee breaks. I'd also like to mention that in our national calls organized by the Research Council of Norway, there is, as a rule, an opening for having international partners involved in the project. So Polish partners, of course, are also invited to take part in those corporations funded with just Norwegian national funding as well. So this is all I want to say. Thank you very much for having me, and very much looking forward to the presentations today. Thank you.
Yes, indeed. At today's conference, we will have a pleasure to see many interesting presentations and hear many interesting speeches, but also have the opportunity of some kind of networking, sharing some informations and gathering some knowledge about funds. Now I would like to ask Marzena Oliwkiewicz-Miklasińska, the head of EEA and Norway Grants team, to carry the presentation on Basic Research Program.
Ladies and gentlemen, nice to meet you. It is my pleasure to represent the National Science Center as the program operator. And because Director Marcin Liana told a little bit about our program, I try to rather tell you about history before we move to the more exciting, meritoric part of our conference. Our program started in December 2017 when the Memoranda of Understanding were signed between donor states and Poland. Next year was dedicated to programming of our program, and in the June of 2019 we because I see that I have a problem with Okay. In June 29, we announced two our main calls, Greek and ID Lab. And 1 year later, in March 2020, last our call for mobility, Pulse, was announced. In spring 2020, the results of Greek and ID Lab calls was published, and the projects started preparing contracting. All projects started in autumn 2020, and in December this year, the results of Pulse call was announced. Now we are more on the halfway of our program, and we are just before our last activity, our last research activity. It will be the assignment of project contracts for the predefined Cryos project, which will be presented after me by Dr. Michał Laska. And this project will be dedicated to cryosphere observation on Svalbard. we spent almost all our money for these projects, and our last activities was funded from bilateral fund of program, and it was the program supporting Ukrainian students and researchers without a PhD. We announced this call in July this year. We received 100 applications, and next week we will probably publish the results of this course. We will finance 22 scholarships for Ukrainian students and researchers. As I told you earlier, we're supposed to sign the last project contract in our program, this for Cryos, in October. And next year probably will be dedicated to program implementation, to progress of all projects realized under this program, with our activities as the program operated to monitoring, to controlling these projects. And we want to announce the last program promoting event probably in the October next year. We will organize the conference dedicated to social science. Now I think it's time to move to meritoric part of our meeting, and I think that you will find these presentations very interesting, very inspiring. I hope that during the breaks will be the time to chat, to discuss about our projects, and in the last part of our conference will also be time for consulting with us, with the members of EEA and Norway Grant team, and we will tell you about the possibility of applying for additional funds under our program. Thank you for your attention, and have a great time during our conference.
Thank you very much. It was an official opening. Thank you for all guest speakers that joined the scene. And now it's time to open the Polar Research session. And this part will be introduced by Michał Laska, University of Silesia in Katowice, with the presentation on the project entitled Cryosphere Integrated Observatory Network on Svalbard.
Right. Madam and gents, it's a great pleasure to be here, and thank you for an invitation. And it's also a very first possibility to present to you our very fresh idea, the Cryos project, which I deeply believe that it might be interesting and useful not only for myself as a principal investigator of this project, but also for our partners. And I hope that also for you, for a person which are interested in polar studies, working in Arctic and Antarctic areas, which I would like to show you on further slides. So the Cryos, the Cryosphere Integrated Observatory Network on Svalbard, is a predefined project and the very last child, the very last baby of the EEA Norway grant. And as you can see here, it's still ongoing. We are still waiting for signing the agreement between our department and the National Science Center and the operator of this project. So as you can see, we've got less than 18 months. That's why the project presented here will be far different than the normal scientific, fully scientific project. But I believe that it might be also a good start point for a next fully scientific research in future. As I mentioned before, the CRIOS is the predefined project. So our donor countries asked the Polish Polar Consortium to have an idea how to spend the money for the polar studies. And that's why we have collected the group of entities which will be able to complete the task within such a rapid time scale. That's why through the Polish Polar Consortium, we've got the application from the 7 Polish entities, which got the permanent logistical centers on the Svalbard. So we've got the University of Silesia in Katowice and Center for Polar Studies, which became the project promoter. And here the responsible person is myself and my colleague Dariusz Ignaciuk, who is also sitting here in front of me. And also the institute, we've got the permanent station as the Hornsund station, hosted by the Institute of Geophysics, and the seasonal stations in Wężel area, in Calypso, Stranda, in Cafiera and Petunia, just to complete the task of this project. It won't be possible without strong cooperation with our Norwegian partners. So we used our contacts with our Norwegian partners, which we have the fruitful cooperation before. And that's why we decided to invite the Norwegian Polar Institute, the University Center in Svalbard, so the UNIS, and the Norwegian Meteorological Institute, the METNO, and above all of them, the SIOS Knowledge Center, which is a kind of an umbrella, which is kind of a consortium developing all the ideas going through the scientific work on Svalbard. And the data sharing, which is very important, which I'd like to present to you further. Right, so what is the idea of the CRIOS? So the idea and the biggest challenge of this project is to create a calibration and validation system for the indirect research. As we can see from the last 2 years, which were completely off on field working on Svalbard, it seems that it might be very important task to have it. As long as we'll have the automatical stations and data transfer, we will have opportunity to fill the gaps, which hopefully won't be present in the future, but it's also always good to have a good quality data, which we would like to share with you within this project. And we will do it by the next objective, so by the modernization and expansion of the automatic monitoring network, which is basically focused on the cryosphere of Spitsbergen. The cryosphere was the major goal from our donor countries, so they asked us to have such a project dedicated, devoted to the cryosphere. So we'll go forward to them and try to figure out the best solution with the broad outreach for the researcher. Then we would like to harmonize and expand the monitoring system. And here we will be talking about 2 kinds of levels. So the level first, which is dedicated to Hornsund, Longyearbyen, and Ny-Ålesund. So the places which are permanently supplied with the internet connection, with the energy power supply, and also to the level 2 stations, which are devoted to the equipping the research infrastructure, which are operated by the Polar Research Unit. So the smaller stations, which is still ongoing on Svalbard for many years. Then we'll try to choose the existing or develop the standardized measurement protocols. Why is it so important? Because all of those entities I presented to you before are collecting the data, are collecting the measurements, they are doing it with a greater knowledge. But when we'll go to the details, some of us are measuring the same system, the same things in a different way, in a different values, in a different coordinates, in a different time scale, intervals, etc. That's why we'll try to make a similar entire system which might get those data comparable in the future research papers. And finally, the major outreach of this project might be the real-time data transfer to the open repositories following the FAIR principles. It might be useful for researchers, it might be useful for policy makers, and for other people, for local societies as well, which might be interested in such a kind of data. For those people who do not know where exactly the Svalbard is, I'll try to present here as the location of our country, of the Poland, and we've got the Svalbard somewhere around 3,000 kilometers from the Silesia region, which is presented with the red cross in the left side. And according to the location of the monitoring system, we'll try to figure out good spatial coverage, and I hope that it might be presented and might be visible here on the right side. So we've got the level 1, it's the red triangles, we've got the Ny-Ålesund, we've got the Longyearbyen and Hornsund from north to south, and then we've got the blue triangles, which are the level 2, presenting the Kafjera and Valdemarbrand, Petunia Bukta and Svenbrand, Calypsobien and Renarbrand, Elveflielia and Velenskjoldbrand. As you can see on the blue triangles, we are divided into the tundra area and to the glacier area as well. So we are talking about two kind of systems which trying to figure the supersite, so the entire area of Svalbard might be specially represented, but the same kind of data that we will have to collect. The structure of the project is divided into 6 phases, and as you can see from this slide, most of them are presented in the next year. So as you can assume, we've got very exciting and super lovely 2023 and 2024 as well. Now I'd like to shortly present to you a kind of a monitoring that we'll try to support. So the CRIOS project is divided into 4 kinds of monitoring. It's coming into the glacier and snow monitoring, to the meteorological monitoring as well, and permafrost plus remote sensing-based monitoring. The biggest equipment is presented within the next slide. So here is the glacier mass, loss, ablation, and accumulation stations. These will be the stations located on the glaciers. It's a kind of a micro station, so beside the snow depth, which is just crucial for measuring the snow depth and ice ablation during the summertime, it's just helping us to get the knowledge about the mass balance of those glaciers under the survey, plus the very basic information from the meteorological point of view. The next one is just the fully automatic weather stations, but in that case, it will be provided with the worldwide satellite coverage by the Iridium network. That's why it will be accessible for all year round without any serious service and trying to delivering data to the repositories by the parts. One of the most challenging things and one of the most important through the meteorological monitoring would be the eddy covariance towers, and it's just a super new for those regions. In the Ny-Ålesund we've got 2, one is still ongoing, but we haven't got any with is going on in Longyearbyen and Hornsund as well. So we'll try to develop a kind of the stations, those 2 kind of stations, in Hornsund area and in Longyearbyen in Alvendalen, maintained by the IGPAS, and the next one operated by the UNIS. It's an infrared spectroscopy which is trying to calculate the fluxes of the CO2 and water vapor and methane fluxes as well. Then we will have some projects according to the permafrost monitoring, and on those level 2 will be simple temperature strings with logger monitoring the ground thermal state up to 10 meters down from the surface of the ground. And a lot of new technologies in remote sensing-based monitoring. In this field, we'll have the possibility to buy the UAVs with the LiDAR, cooperate with the satellite system of probably with the Planet One, according to dedicated area of interest for the entire time of the project. We'll have 4 time-lapse cameras for Tundra only, INSAR and corner reflectors, and the GNSS receivers for calculating the snow volume. I wouldn't say much more words here. If any of you are interested in that field, what kind of things or what is the details of that equipment, I'll gladly inform it to you afterwards, right after this session. Right, so what are our activities in 2023 and 2024 besides buying and installing the entire equipment? So the good opportunity to meet with each other, with entire society, would be the Polar Night Weeks, which are conducted by the SIOS for many years. And the first one will be in the end of January 2023 and the end of January 2024. The first one is already informed, so it's already presented. Within the next weeks, probably there will be a submission. All of you are just welcome to see what is going on in the polar countries, in the polar regions, in the polar science. And within those meetings, we'll have the CRIOS workshops. We'll like to have opportunity to meet with our partners, to develop the good standards for our projects, and to weigh how our equipment would be installed, and finally, how it would be measuring the interesting things of the cryospheric environment. Further, if you are the outstanding master degree or PhD students, we will also invite to you, or have some under your supervision as well. We'll have a call for 5 travel grants for UNIS courses. As you can see, the UNIS courses are very special because it is nicely sharing the field working knowledge with the deep scientific knowledge within the laboratories at UNIS at Svalbard. So we'll wish to grant such a 5 travel grants for the society, for those which are very, very active and needs to push a little bit or help in the very early research stage. And coming to the end, because it's still too early to talk about the results, I would like to acknowledge, and I would like to acknowledge the organizing parts which we were invited here. We, at our very short way, have a few good ferries, and one of such a ferry is my previous presenter, Marzena Miklasiewicz, Oliwkiewicz-Miklasińska, I'm sorry, I'm trying to figure out, there you are. She was fighting like a lion for this project and raised me up when I trying to lose my faith in this proposal. That's why from the bottom of my heart and on behalf of our partners, we are very glad for this cooperation here. And also, thank you for the attention. If there are any questions, I'll gladly try to answer them here, or maybe later. Me and Dariusz are for your questions for this time. Thank you very much, and have a good cooperation, and have a good meeting here. In case of permafrost monitoring, we're interested at this moment only for a temperature of the ground. So the borehole drilling will be dedicated only to install, to have the installation. But it might be also a good opportunity to think about the collecting the sample during the core drilling and trying to sample it in that field. If you are just interested in that. At this moment, we haven't got any, with that portion, because we are still ongoing. So we are trying. We find the good spots to prepare those samplings, but we haven't got opportunity to drill them. I'm not sure about the equipment which will be dedicated for that task. Would it be possible to collect any kind of samples? But if does, and you've got an idea how to use those data, we are open to share with it. Yeah, that's why, as I presented to you, we wish that we won't stick only for a cryosphere. The cryosphere, in that case, is the basic, but the cryosphere is mixing with the different kind of the spheres, of the Earth spheres. So as long as you feel and see the opportunity to cooperate in that field, we are just open for you to for such a possibilities. That's why we are just here. Thank you. Any other? Yeah. Thank you.
Thank you very much. It was Michał Laska from the University of Silesia in Katowice. Ladies and gentlemen, if you will have any questions after the presentations, please raise your hand. I have the microphone, so also the guests, viewers who joined online will also hear your questions. And the next presentation will be held by Jan Pawłowski from the Institute of the Oceanology, Polish Academy of Science, and presentation on the project entitled Sedimentary Ancient DNA, a new proxy to investigate the impact of environmental change on past and present biodiversity in Nordic seas.
Thank you very much. Good morning. Thank you for this opportunity to present the... Can you hear me? This opportunity to present, I think, one of the first presentation of this project, and also for this spectacular scenery here. This is, I think, the first time I saw how beautiful Gdańsk is and all the tricity here. It's a unique occasion. Okay, so coming back to this, the project is called NEEDed, and I think that everybody understands what is needed here, just watching on this picture. So I think the most simple way to formulate it is what at least we need is that this is not a postcard that will become a souvenir. This picture comes from North-South from Svalbard, and we hope that this will remain and it will not just disappear. So what is needed to do it? One of those many things is needed, but one of the thing that is needed is to understand the process that is coming with the climate changes and what is kind of how these environmental changes have the impact on marine biodiversity. So we know all about what is the impact on these more like emblematic animals like polar bears, but we want to know what is the impact on the whole ecosystem. And whole ecosystem is basically based on microbes or small-sized animals. And this is what we will do in this project. This is what we intend to do using DNA. So I will just present shortly the project team. So this is a collaboration between IOPA, so Institute of Oceanology in Sopot, and Norse from Bergen. The team is composed of two categories of kind of scientists. From one side, we have geologists, paleoceanographers that work on the ancient material, fossil material, and then on both sides, we have the people who work on the molecular work. So it's like a combination of these two domains that we hope will provide us with very interesting results. There's also the project allowed us to engage two postdocs, one postdoc in Norse, in Bergen, one postdoc in Japan, and then two PhD students that are now in Sopot. So there's a real people who are doing their PhD student thesis and working on the science part. What is the objective of this? As I said, the objective is to use DNA, let's say, as a complementary, I wouldn't say replacement, because that may not be likened by everybody. But the question is how to do all this kind of analytical studies without microscope. Or this doesn't work, but it doesn't matter. So coming from microscope, which is like classical way to observe the biodiversity, to the sequencer, which will be another way to get in a very different way. So going more correctly from microfossil to paleogenomics. So as you probably hear, the paleogenomics now is very famous because we have Nobel Prize 1 week ago. And, but this is more about environmental paleogenomics. So this is this part of the science that is not only looking after bones and DNA that is in the bones, but the DNA that is in the sediments or air or water. So the biggest difference is that if you work with the microscope, you have some kind of limited access to the biodiversity. You only can see what is preserved in the fossil record. And finally, there's not so many organisms that kind of construct the shells or construct the skeleton that can be preserved in the sediment. So this is the most important limiting factor compared to what is really living in the sea. There's only minor part here, for example, foraminiferans or diatoms or radiolines. This will be this kind of typical microfossil. But this is only very limited part of the biodiversity. When we do the sequencing, you can get everything. Practically all organisms living on Earth have DNA. And all of them have certain part of DNA that we can amplify and obtain and then sequence. So this is the only way, really, to get the holistic overview of processes and changes. And now we have to go and see how we can use this paleogenomic inside the downcore, inside the sediments. Okay? So the methodology is relatively well known, probably for all microbiologists and molecular biologists. It consists on taking sediment, getting DNA extracted from the sediment, then amplify the fragment. You don't need to amplify. You can also do some kind of what we call shotgun sequencing, so you can just sequence everything. But somehow this PCR amplification is interesting because it's allowed us to target certain groups. If you get everything, for example, from sediments, most of your DNA will be from bacteria. And you will have a lot of problems to obtain, for example, DNA of higher organisms. So that's why PCR can be interesting. And all this process is called metabolic coding, so some kind of, amplification. Then you get sequences, and then you get all this bioinformatics to, at the end, finish with biodiversity, taxonomic assignment or not, depending on your database and so on. So this is relatively well known. This is already well established. The problem is we apply this to the ancient sediment, to the sediments that go down practically now almost 1 million years. You can get the DNA from much older sediments. Coming to the project was, I would say, evolving a little bit, because if you remember the dates, these dates come in 2020, and 2020 was not a good moment to start any kind of collaboration, so everything is delayed, everything gets kind of, modified, and this is how we imagine this project in 2019. We will see this as a kind of two workflow with DNA and paleo, and then the idea was that the samples will be mainly collected by Polish vessel that we have seen, Oceania, and then that DNA will be done mainly or in the same, but mainly in Norse, in Norway, because this is where the labs were, and then the part of paleoceanography will be done mainly in Poland. Then at the end, this has changed slightly because we were able, thanks to the fundings from the Institute, to develop the ancient DNA lab here in Sopot. So part of it is now done in Sopot, part is done in Norway. And also, it's very important that we were unable to use in 2020 the ship to go to Svalbard or any kind of Nordic Sea. So at the end, the samples came from Norway. And the Norwegian were the samples that were then analyzed. But I think this is normal. We have to be flexible. Nobody knew about COVID in 2019. And then, that's how we started to adapt it. There are 3 work packages. One of them that I'm responsible on is about the eDNA taphonomy. So eDNA, environmental DNA taphonomy, is a kind of understanding what's happened with DNA when this DNA is getting down to the sediments. It's not very well understood. We know that we can take DNA from water, we can take DNA from sediment, we can sequence, it's okay. But if you do this sediment sequencing, do you really obtain everything what is in the water column, or what you really obtain? And this is very, very important, because our objective is to understand what's happened on the surface just by looking on the sediment. All organisms from the surface fall down to the sediment, but most of them degraded, disappeared, somehow, are not preserved. So the question of taphonomy is to understand, and we take the samples to approach this. We take the samples from the surface, we take the samples from the middle column, water column, and then on the bottom water column, and from the sediment. And we are just comparing these different sequencing data sets, and then with this, we will be able to say how much the sediment are really a reflection of what's happened on the surface. Because honestly, most of the problem comes from the surface. This is where most of changes are. This is where sea ice, for example, is melted. So there's very important changes. There are also changes on the bottom related to the water mass circulation. That's another question. But these changes are relatively, for a moment, minor compared to what's happened in the water surface. So this is first part of the project. The second part is paleoceanography. So this part is mainly done in Sopot here, thanks to all these different fancy instruments that they have to analyze the sea surface and the sediment cores, the dating of sediment core, and also sea ice construction using alkanones, and also for productivity and carbon burial. So everything, this part is mainly done by specialists in Poland, in collaboration with specialists in Bergen. So, and this is very well advanced now. Then the third part is concerning directly environmental paleogenomics. So we are very happy now. We have this DNA lab. You see this very strange person here that can go inside only if they change their clothes, and everything is totally sterilized. Everything is filtered. It's one of the few this type of labs that I know about, especially those that are able to do sediments, because a lot of them working on bones, but the people who work on bones, they don't want to have sediments in it because they think it's too much dirt. So they want to have only very clean bones. Here you can really, everything is adapted to take the cores, like on the upper part, and get the samples out of cores and then analyze them. So this is, everything is now ready for this. We have done a lot of work. This is about what we are really looking for. This is kind of leading hypothesis of all this project. In fact, what we observe here under what we called recent warming, so this is today, already been like that. The temperature was already very warm. It's about a few thousand years ago in mid-Holocene. So going through this course, we will see whether we try to see whether we can obtain the same situation on DNA, on this ancient DNA that was a few thousand years ago in mid-Holocene, and compare to what has happened recently. Between both, there is a little ice age where the situation changed. And if everything works well, we will obtain this kind of situation where we have a lot of diversity in the mid-Holocene, then this diversity in the Arctic Ocean disappeared. There's a lot of productivity, but as you know, all the biologists know, that where there's a lot of productivity, there's a low diversity. And then today, the situation is reversed. We are coming to higher diversity and low productivity. So we hope that we will be able to see the same patterns and then to understand how these things changing over the time, because this is what we want to really know. We want to understand the processes, how this ecosystem react to the global warming. And we can do it just by looking on the past. So, yeah. So coming back to the practical part, we have, as I said, for the sampling, we are very grateful to our Norwegian colleagues that went and sampled in 2020, where Polish scientists were not allowed to go on Norwegian ships. So these samples were done in November 2020, then July 21, and then finally in summer 21, we also could use Oceania for getting samples. This is a team from Norway and from Oceania and from Sopot that was doing. We have now 13 sediment cores, so it's quite more than even we were planning. I think there were 6 cores planned. There's also water samples that are necessary for the taphonomy stuff and surface sediment samples that will be compared. And most of the work is done in what we call Nordic Sea, so between Greenland, Svalbard, a little bit closer to, and also some cores come from Faroe Island. So this is more or less the area that we are doing. So it's just, I don't want to be too boring about the science, but this just to show that the work is progressing smoothly. We already have all this paleosonographic work done here for one of these Greenland Sea cores, where we can really date the core, we can obtain the productivities, and we also see what are the changes in the diversity of different groups. Of course, microfossils, because this is all done on microfossil, and this is compared to the genetic data that for a moment we cannot really, we didn't obtain yet the data, so we did part of it concerning the diversity in Svalbard, where we could see that there is an impact as a general trend to impact of Atlantic water towards Svalbard, which brings the changes in the diversity on western part of Svalbard, which is on this kind of, I cannot really use it, but on this right part, where there's less diversity, and then there's this part, Ejoya, and also North Icelandic, that are part of the eastern Svalbard, and then we see much, much higher diversity, and this is more impacted by Arctic water. So the system works pretty well. Now we're still waiting for the results from the sequencing. So everything is now, as far as I understood, in some kind of sequencing platform in Warsaw, and hopefully this month we will get the sequencing results. So something is practically finished. Selection, of course, for dating has been done. Some of them has been already dated. Paleosonographic analyses are ongoing, so this is fine. There's no any particular problems. We also get this eDNA lab, which allowed us to do parallel work. Part is done in Bergen, part is done now in Sopot, and now we are just waiting for the results. So the next time I will bring the results and show you how it is. Okay, thank you very much. Yes.
I have one question to ask. You said about the sampling of sediments, and what kind of sediments are best for preserving ancient DNA? Yeah, because I recall the lecture. I just 3 weeks ago I was on the conference, and Stefan Jorgensen from University of Bergen was talking about some kind of estimation, of the. And he was looking for correlation between the sediment depth and the possibility to recover ancient DNA. And I was impressed because he was talking about the range of 20,000 years. So it was impressive.
Well, we can go now in my lab. We go to 200,000.
Yeah,
quite easily. But it's very complicated to get the community. We have to understand that the DNA is degrading with time, and the real community can be obtained, in my opinion, very personal opinion, down to 100,000. Then you just get some DNA, but of some very sporadic organisms. Now, the first question concerning the what sediment is the best, I would say this is 1 million question. I don't know answer. Nobody know really answer. But it's for sure that this is not good if it's a sandy sediment. You still have the DNA, but it's very difficult to work with a sandy sediment. I think that it probably is, there will be some relation with silicates and clay. So if you get a clay, that clay will kind of act as attaching the DNA. Everything depends how this DNA can stay stable. And it's still degraded, but we can get it even from degraded DNA. This is all degraded anyway. But the question is, we don't want to have it completely disappeared because of some kind of acids or some kind of conditions. But the exact answer, I don't think there is known exact what should be the sediment type. Okay.
I have one question. Did you sample also the water close to the glacier as the water from the glacier or the outflows beneath the surface water are full of the sediments, and probably there is a lot of inflow of the ancient DNA from the land to the ocean and to the system fjords? Did you look on that, how it influences the sediments?
Not in this project,
Okay.
because in this project the attention is more on the open sea and long course taken from the sea. But it's interesting, but this kind of sediment is already kind of recirculated. So I did it in Antarctic on the sediment that is on the ice, and you can get it, but it will be very difficult to separate the DNA from the sediment from the ice and from the water. So it's more complicated because it's like already in some kind of circulation.
Yeah, but it will be nice to look on that if you are talking about the warming period and higher biodiversity. It will be influenced of the higher glacier melting and transfer of the material from the glacier. Yeah. Thank you.
Thank you very much for a very interesting presentation, and we are heading to the next topic. It will be presented by Adam Sokołowski from the University of Gdańsk, a presentation entitled Transport via Ocean Currents of Human Pharmaceutical Products and Their Impact on Marine Biota in European Arctic.
Good morning or good afternoon, everybody. I work at the University of Gdańsk, Faculty of Oceanography and Geography, Institute of Oceanography in Gdynia, and I'm pleased to present to you a short overview and the first results of the research project entitled Transport via Ocean Currents of Human Pharmaceutical Products and their impact on marine biota in the European Arctic. The short name is PharMarine. The project was funded within the Greek One Call in 2019, and that was operated by the National Science Center in Kraków. And the project involves 5 partners: University of Gdańsk as a leader. Then we have SINTEF from Trondheim, Institute of Oceanology, Polish Academy of Sciences in Sopot, University Center in Svalbard, Longyearbyen, and Medical University of Gdańsk in Gdańsk. The total budget of the project is slightly more than 6,300,000 zlotys. That corresponds to nearly 1.5 million euros, and it covers 100% of the requested funding. At the very beginning of the project was inspiration that came from emerging facts that the consumption of pharmaceuticals is increasing, and the release of drugs into the marine environment is rising as well. Human pharmaceuticals, so pharmaceuticals used in human therapy, comprises more than 1,000 biological molecules now, but their use vary across continents. In Europe, for example, In Europe, for example, the massive use of pharmaceuticals includes primarily non-steroidal anti-inflammatory drugs and analgesics, while in North America there are different drugs. In Oceania, Antarctica, again, the consumption is focused on different groups of pharmaceuticals. According to the recent predictions, the consumption of pharmaceuticals across the world will be increasing over the next decades. Taking the example of German prognosis, for example, it is clear that the pharmaceuticals will be used in a massive way over the next 35 years, and the increases from 43 until 69% over the next 30 years. Human pharmaceuticals comprise a high variety of chemical compounds that are grouped into several classes: antibiotics, non-steroidal, anti-inflammatory drugs, central nervous system drugs, analgesics, analeptics, and illicit drugs. Some of them undergo biotransformation in the organisms, but the biotransformation products can remain biologically active and can exert effects on non-target organisms, like marine organisms. The drugs show also a high variety of chemical structure, inducing different physicochemical properties like polarity or solubility, and behavioral in the marine environment, including photochemical degradation, hydrolysis, and bacterial degradation. Most pharmaceuticals, fortunately, degrade readily in the marine environment, and they are not anymore active. But some of them can remain persistent in the marine environment, even if they undergo biotransformation or chemical transformation. They can remain biologically active and can have biological effects in the marine environment. So there is a high potential for human pharmaceuticals to remain biological activity in different areas in the marine ecosystem, and this is what we are worrying about. The pharmaceuticals become, therefore, the environmental concern, and they are now considered emerging contaminants also in European Arctic. The drugs show high concentrations in coastal waters, specifically close to the large human agglomerations. They are fairly unmobile in the marine environment, so it is very likely they can be transported over long distances and have biological effects on non-target organisms in remote locations, including European Arctic. So given the specific physical-chemical properties, high concentrations in the marine environment, a high volume of release into the coastal waters, and also elevated levels in many areas along the Europe, it is possible that the pharmaceuticals will be transported from mid-latitude areas from the mainland of Europe to the European Arctic. And this topic forms the main content of Work Package 1 of our project. So the transport of pharmaceuticals, potential transport from the mid-latitude areas to the European Arctic. That's amazing that information about pharmaceutical concentrations in European Arctic is very scarce. A number of investigations on drug concentrations is very low. So we would like also to assess the contamination status of pharmaceuticals in the European Arctic. And this is the main aim of Work Package 2 in our project. As you can see on this map, for example, a number of sampling sites and research sites in the Arctic is fairly low and concentrates mainly in Greenland and the Canadian Arctic, a little bit on Iceland, but not much is done so far in the Spitsbergen area, for example. Work package 2 investigates also whether the pharmaceuticals can be transferred in the marine food web. So the topic related to biomagnification of pharmaceuticals is also one of the aims of Work package 2 in our project. Once in the marine environment, a number of pharmaceuticals remain biologically active and can have biological effects on non-target organisms. These effects vary a lot depending on the level of biological organization. So they include genotoxicity, physiological modifications, endocrine disruptions, behavioral changes, morphological deformations. There's a large array of potential biological effects we can expect looking at physical chemical properties and concentrations of drugs in the marine environment. And biological responses of benthic fauna to selected pharmaceuticals form the main content of Work package 3 in our project. Before the project started, we decided based on several criteria like normal priority list of emerging contaminants, physicochemical properties, release rates to the marine environment and concentrations in marine water and sediments, which drugs will be concentrated in the project. We selected 4 of them, diclofenac, fluoxetine, simvastatin, and tetracycline as the key compounds that will be investigated during the project implementation. So the project comprises 4 main work packages focusing on transport and biopathways of pharmaceuticals to the European Arctic within Work package 1, contamination status and potential biomagnification in Work package 2. Then we have biological effects on marine benthic fauna in the European Arctic within Work package 3, and finally project coordination, management and dissemination in Work package 4. A few words about so far activities and the results. In the first phases of the project implementation, we focused on potential distribution and transport pathways of pharmaceuticals from mainland of Europe to the European Arctic. Using the scene model and based on information on release volumes along the European coast and the production of pharmaceuticals, consumption rates and dynamics of chemical and biological transformation in the marine environment, we tried to simulate potential transport of drugs towards the European Arctic. And the resultant data show evidently that pharmaceuticals can be transported over a long distance and can reach the Arctic within 1 year after the release. Looking, for example, at these simple graphs, on left-hand side, you see the distribution pattern of diclofenac 6 months after the release, and on the right-hand side, there is a map of distribution of the same drug 12 months after the release along the European coast. And we can see easily that there is a potential for pharmaceuticals to reach the Arctic within a year. Those simulations were used then to define location of sampling sites for the field study. In summer 2021, during the campaign of research vessel Oceania, samples of water and zooplankton were collected along the profile going from mid-latitude areas in Europe, Baltic Sea and the Norwegian Sea, then along the Scandinavian peninsula towards the Arctic to collect samples and analyze them for pharmaceuticals in order to assess indeed potential transport towards the Arctic. Water samples were treated immediately on board using large volume solid phase extraction system that were built in on purpose for this campaign, and the capsules contained sorbents which absorbed pharmaceuticals in a safe way. The same summer, samples of benthic fauna in the Arctic were collected in 3 fjords, Kongsfjorden, Isfjorden, and Horsund, to assess contamination status of pharmaceuticals. And the scuba diving team collected also selected compartments of food web to analyze potential biomagnification of pharmaceuticals in the Arctic food webs. At the same time, laboratory tests were performed to develop extraction methods for biological matrices, and the first measurements of pharmaceutical concentrations were made on the samples collected during the 2021 campaign. And the first results, for example, you can see that 2 pharmaceuticals, carbamazepine and fluconazole, showed northward gradient, which can indicate that the origin is landborne. This summer, 2 biological experiments were run in a Nealesund infrastructure using 2 dominant Arctic species, sedentary bivalve Chlamys islandica and mobile crustaceans Gamaros oceanicus, that were exposed to several concentrations of 2 pharmaceuticals, carbamazepine and norfluoxetine. The samples were collected and now are analyzed in Polish laboratories. And finally, we are going also to perform long-term experiments using a dominant species, Calanus finmarchicus, to define dynamics of pharmaceuticals consumption and depuration. We are also going to complete the analysis of pharmaceutical concentrations on samples collected in the field and during the experiments. And finally, we are going also to analyze experimental samples for an array of biological biomarkers to see whether there's an effect of pharmaceuticals on benthic organisms in the Arctic. More detailed information about the project can be found on the project website and Facebook, or you can contact us directly by email. Thank you very much for your attention.
Are there any questions? Thank you very much, Adam Sokołowski, University of Gdańsk, and now we are heading from the University of Gdańsk to University of Wrocław with the presentation of Jan Kavan-Svelta, Svalbard Delta Systems under Warming Climate.
So, thank you very much, and good afternoon, ladies and gentlemen. I'm quite impressed with the previous speakers, with their great project, so I will like to present our project, which is quite tiny in comparison to the previous ones, but still I hope the results will be as good as the previous ones. So, Svalbard deltas, we choose this topic because delta systems are just on the edge of the terrestrial and marine ecosystems, and we consider it as a good indicator of what's happening in the whole Arctic geosystem. So we already saw the map of Svalbard, but I just wanted to show some background information, which were also like factors that lead us to choose this study site. Svalbard is one of the northernmost landmasses in the high Arctic. It's covered by glaciers of about 60%, and in the recent years, this region is considered as one of the most rapidly changing in the whole Earth in terms of climate change and global warming. And for the practical reason, there is a good accessibility. You can easily go to Svalbard, and there is long-term observations, both of climate data, aerial images, and everything. So it's very kind of good natural laboratory for studying these processes. So the aim of the project is to study and understand how the delta systems are responding to the recent climate warming, and what are the controlling factors that affect the development of the delta system, if it's like the glacier retreat, permafrost degradation, or basically the whole landscape transformation. So we have several basic research questions. So first of all, basically nobody knows or nobody studied the delta system, so we need to make some kind of inventory and see how the deltas developed during the observational period during the 20th century. Whether these systems are dominated by progradation or erosion, if the deltas are growing or decreasing, and what are the key factors that are controlling the seasonal morphodynamics of the deltas. And if we answer all these questions, we would like to also have idea about the possible future or some kind of prediction what will happen in Svalbard or generally in the higher Arctic in the future. So the project is split into three tasks or working tasks. The first one is using remote sensing for analyzing the long-term changes. So basically using the historic aerial pictures, satellite imagery to see what was going on in Svalbard in terms of development of the delta systems during the 20th century. The second task, which is based on fieldwork, is to see how the dynamics of the deltas are during short term, like during one summer or in between of the 2 years. And at the end, we would like to make some general picture or to have some schematic model of how these systems are developing and what can we expect in the future. So I can already show you some preliminary results and outcomes. So the analysis of the historic images was quite surprising for us because it seems that most of the deltas are very stable during the whole 20th century, despite all these great changes in glacial retreat and global warming, rising the temperatures. It seems that the delta systems are quite stable and don't react quite a lot on these changes. However, there are few individual sites where the deltas are really dynamic, and this is usually connected to dramatic changes in the glacier system, such as the surge events. This is one example, a fresh one, where a brand new delta has been formed. I'm not sure if this is working. Yes. So in this lower part, you can see in 2019 there was nothing, and during the summer of 2020, on the picture on the right, you can already see a brand new delta that is formed during the 2 or 3 months of the summer 2020. And it looks like this nowadays. So basically, during one summer, a brand new delta has formed in the size of about 1 square kilometer, which is quite huge. So we already managed to publish 3 articles, and we have some more submitted. So I will just show you the highlights. So the first one, we studied the historic digital elevation models and extent of the glaciers on the east coast of Svalbard. And we managed to have quite a nice idea of the glacial retreat in this particular part of Svalbard, where the glaciers are retreating quite fast and the new coastlines are appearing. And the new coastline is usually, after the glacial retreat, it's filled with the sediments that are then transformed. And quite often also new deltas are appearing in these kind of systems. It's one actually of the most dynamic regions in Svalbard in terms of glacier mass loss. So you see that some of the glaciers has lost almost 100 meters in the last 50 years in terms of their thickness. Svalbard is not really much populated, but we cannot forget on the human presence. So we also investigated the interference between the natural processes and the human presence and activities on the example of the Pyramiden. As you can see, Pyramiden is actually now abandoned Russian city, but it was built just... Sorry, the pointer is not working, but the Pyramiden was actually built on the delta or on the edge of the delta. So there are still some active processes that are affecting the infrastructure, as you can see on the next picture. So it's like the edge of the delta, which was in 2006, I think, cut through like a flood event, and there was quite a huge erosion in the city. So it's kind of example that the natural processes are also affecting the human infrastructure. We concentrated more to study the remote sensing data, and one of the key factors for the delta development is the supply of the sediment from land to sea. So we tried to use Sentinel-2 images to quantify the influx of the sediments to the marine system. And we used Sentinel-2 images to quantify the sediment influx from the glaciated catchments towards the sea. As you can see on both of the pictures, the sediments are actually creating a huge sediment plumes, which are quite easily detectable with the remote sensing techniques, and this can be also quantified. So we were able to reconstruct the seasonal changes of the sediment supply, which is basically the yellow line, where you see the biggest peak in the middle of the summer, when also the temperatures are the highest and the inflow of the sediment from land to the sea is highest. And this is just a schematic picture of how the system works. The retreating glacier is releasing quite a lot of fresh material, mineral material, sediments. And then the fluvial activity, the rivers are transporting the material to the lake or then to the sea. So at the coast of the sea, the new coastline is changing and forming. We also looked how the tidewater glaciers are actually transporting the sediments to the sea. And we picked up one particular glacier just to study it in the central Spitsbergen in Petunia Buchta. And we tried to connect all the features that are detectable with remote sensing, like sea ice extent, superglacial lakes extent on the surface of the glacier, and then the sediment plumes. And we tried to describe this process, which is quite short, during the Arctic summer, like 2-3 months. And we also confirmed the peak of the transporting season to end of July or beginning of the August. And we were quite lucky, actually, at the beginning of the project in January. There was really a nice paper in Nature published by the team from Norwegian Polar Institute, and we used their data to investigate more on the new coastline development and appearance. So since 1936, where we have a lot of data, there is almost 1,000 kilometers of new coastlines that appear after the glacier has retreated. And this is the new coastline, which is fresh, full of sediment material, non-sorted, non-consolidated. And this is then transformed by the sea actions to new coastlines, new beaches, ridges, and also deltas. And the paper, which is ready to submit, deals with the seasonal variation of the delta extent, because some of the deltas, which are quite shallow, so as you can see on the picture on the right, in the colored lines there, the lines are expressing the actual position of the shoreline when the image was taken. So you can have 20 or 30 satellite images during the season, but each one shows different position of the coastline, depending on whether it is high tide or low tide of the sea. And this is quite important when you are trying to estimate the long-term changes in the systems, because you take the picture from, 1960s, but you don't know if it was taken during the high tide or low tide. So then the whole long-term trend could be deviated by this. So we tried to enlighten this problem in the remote sensing data, and it's almost ready to submit. And this summer we also moved to the phase 2, the fieldwork, And the fieldwork consisted of mapping of the chosen delta systems with drones. And now we are just processing the digital elevation models and orthophotos. And we will try to come to the same spots next year to see how the spots were, how the sites, how the deltas are changed during the 1 year. And we also set up some time-lapse cameras to see whether there are some important changes, like within the delta, within one extra summer season, within the 2 or 3 months of the Arctic summer. And just to sum it up, as I already told you, we were quite surprised that there are almost no changes in the Svalbard deltas, which is quite surprising because, for example, in Greenland or other parts of the Arctic, the deltas are growing in a really fast tempo. It's like hundreds of meters per year, even in Greenland, but Svalbard is really stable. But we found some proofs that there are some individual sites with dramatic changes which are connected to mainly glacier dynamics, the surge events or glacier-like outburst floods. And these short dramatic events can create a new delta, as you saw at the beginning of the presentation. And it seems that with the ongoing mass loss of the glaciers, there will be still less and less water and less sediment influx from land to the sea. So probably the deltas will stay stable or will even undergo some small erosion. So that's all from me, and thanks for attention.
And are there any questions?
Hello, thank you for this very nice talk. Are you planning to also look on the biodiversity of organisms living in delta, or this is only about the delta cartography?
Well, it's an interesting question, but it's unfortunately quite far away from the project, which is basically quite small. But it's interesting. We have some radiocarbon dating samples from the past deltas. So at one point we can reconstruct the biodiversity for shells and for diatoms, but it's not directly in this project, but the samples are available.
Thank you very much, Jan Kavan from University of Wrocław. And now we have prepared the presentation. The presentation was prepared by Anna Pienkowski-Furze from Adam Mickiewicz University in Poznań. Unfortunately, Ms. Anna is not with us today, but she gave her comment on the presentation and she recorded her voice. So we will hear this presentation in a moment. The project is entitled Changing Antarctic Marine Environment. So please enjoy the presentation.
Hello everyone, my name is Anna Pienkowski and today I'll give you a brief outline of the CHARM project. CHARM stands for Changing Antarctic Marine Environments and it is a project based at Adam Mickiewicz University in Poznań. I am PI on the project, but there are many more people involved and you can see their names here. And the project has been funded by the PULSE program, which is a joint initiative between the National Science Centre Poland and Norway grants. The background to the project is a topic that has really been quite prevalent in recent times, and that is climate change, and in particular human-driven climate warming that our planet has experienced. And some of the regions that are most affected by this climate warming have been the high latitudes, so the Arctic and Antarctic. And some of the most visible signs of these changes that have been initiated by climate warming has been the decline of the cryosphere, so the frozen components such as decline of glaciers, ice sheets, and sea ice. And any of these changes will cascade through the system and affect other parts of the Earth system, such as, for example, the biosphere, the ecosystems, because everything is so tightly interconnected. And CHARM focuses on a region that has shown quite profound climate warming over the last few decades, and that is the Antarctic Peninsula. You can see this graphic here by NASA, which shows climate warming and the level of warming over the past 5 decades in this part of the world. And of course, any of these physical changes will also potentially cascade and affect other components such as ecosystems in these regions. And so CHARM aims to trace these changes that we see in these environments and in these regions in terms of the sedimentary record. So we aim to fingerprint the indicators that we see in the seabed, which can best tell us about the modern marine-based ice retreat along the Antarctic Peninsula. And in particular, we have 2 objectives. The first is to identify proxies or indicators from previously living organisms, so biogenic proxies, which most faithfully reflect parameters such as sea ice, ocean temperature, and distance from the glacial ice edge. And secondly, building upon that, to test these proxies in terms of reconstructing environment and environmental change over a longer time period, so going back decades to hundreds of years. And we will be doing this by looking at sediment cores. The study area are 3 fjords along the Antarctic Peninsula in a really nice north to south transect, you can see here. And all of these were, until recently, covered by floating glacial ice, so by ice shelves, ice tongues. And the retreat of these cryospheric components has been well documented by satellites. So we have a good grasp on how these environments have changed over the last few decades. And we have systematically sampled these 3 sites from the glacier edge right out to the fjord entrance, to the outer fjord towards the open ocean, and that sampling has been done before the project, the CHARM project, started. And within the seabed, we are interested in these preserved characteristics, so proxies that stand in for direct measurements. And this is a very powerful way to then go back into the past and reconstruct past environments and past climate. And we focus on biogenic proxies for a suite of things from micropaleontology through to chemical fossils such as biomarkers, as well as techniques such as sedimentary DNA. And in CHARM, we are using a multi-proxy approach, so looking at many different indicators. And I just want to focus on a few things here. I cannot present everything because there's not so much time, but one of the tricky things to reconstruct in terms of a parameter, even though it's such an important climate parameter, is sea ice. And the tricky thing is that most of the proxies we have are not directly dependent on sea ice. And so one way around this is to look at compounds of chemical fossils that are strictly produced by sea ice organisms such as diatoms. And this is where HBI biomarkers come in. So IPSO in particular is a compound, IPSO25, that is synthesized by sea ice diatoms and is a good spring-summer sea ice proxy. And then within the suite of proxies, we also, or within the suite of biomarkers, we also have compounds that are produced by open water phytoplankton, also diatoms, so HBI3 and HBI4. And we look at these in tandem, so both the compounds produced by sea ice diatoms as well as those by open water diatoms. We can put those together to come up with spring-summer sea ice as well as phytoplankton blooms at the marginal ice zone. And here are some results. This is from work package 1. So we're looking here at surface sediment, at modern sediments that were taken in 2018. And what kind of trends do we see? Well, first of all, we see that biomarkers are present in all the samples. So that's quite a good result. And what else we can see is that if we look at IPSO25, the blue column, so the compound produced by sea ice diatoms, we can see that the concentrations increase as we go from north to south. So the higher the latitude, the more of IPSO25. And we also see that within these fjords, so 1, 2, and 3, we have an increase in IPSO25 as we go from the glacier edge right through to the entrance of the fjord, so towards the open ocean. And within the other compounds, HBI3 and HBI4, we can see that the trends in terms of increasing away from the glacier edge also hold here. If we now shift to the marginal ice zone, we see that actually blooms are more prevalent the farther south we go. So if we go to that third fjord here, we see more of the blooms in comparison to the other sides. And in particular, the northern side almost has no blooms here. And we can also translate these results, the ones I've just shown you, into maps, so weighted averaging maps where we can trace the kind of trends in a more mapped characteristic. And we see here these trends of IPSO25 here, HBI3 and HBI4 increasing in terms of concentrations away from the glacier edge. And some other compounds that we have also analyzed are sterols. So within the sediments, there are many different chemical fossils we can look at. And here are just two of them. So dinosterol produced by dinoflagellates and desmosterol produced by diatoms. And the results here are a little bit more complicated, but one of the things striking, I would say, is that desmosterol seems to be a bit more prevalent nearer to the glacier edge, so nearer to the fjord head, which may be a good indicator then for distance to the glacier edge. A few results also from work package 2, so looking at the longer time, going back farther in time, the last few decades to hundreds of years. If you're wondering why there are no data here, it is because we're still working on it, but the cores also look very promising. There's quite a few visible trends in terms of concentrations of both sea ice and open water biomarkers, so there's ongoing work, but I think it looks quite promising to be able to decipher these environments, not just in the modern, but also through time. And of course, one thing to really emphasize here is that there is a bigger picture, so that even though we're looking maybe at modern and quite recent environments, everything is very tightly interconnected, so past, present, and future. So if we can improve our way of deciphering these environments here by looking at surface samples and link the distribution of microfossils and chemical fossils and sedimentary DNA to environmental parameters, we can come up with far better and more faithful ways to accurately reconstruct past environments. And that, of course, then helps us to suss out maybe periods in our Earth's history, in our climate, that are parallel to what we may see in the future. So that knowledge of proxy-environment relationships is really fundamental to that. And I end with this very cute seal here. Thank you for listening. If you want to check out the website, I've put it up here. And if you want to be updated on what's going on in the project, we have Twitter and Instagram accounts. Thank you very much. Hello everyone, my name is Anna Pinkowski and
Ladies and gentlemen, so we have heard 5 very interesting presentations and speeches. And now, before we start the next session, climate research, we will invite you for a short lunch break, which will be until 10 past 2 o'clock. So please enjoy your lunch, and we will see each other after short break. The lunch will be served here in this room. Ladies and gentlemen, we will start the second part of our today's conference. So please take a seat. In a little while we will start. But what I wanted to say, you can see on the screen a sketch note, which was designed by Anna Szczepkowska, visual coach, which is a reminder, and I think the notes from today's conference illustrated in a very visual way. Before, in the previous part, we had a polar research session, which was very interesting, with 5 presentations and speeches. Now we are proceeding to the climate research panel. It's the second panel of today's conference, and this panel will be beginning with a presentation provided by Mateusz Gregoruk from Warsaw University of Life Science, with the presentation on the project entitled Forecasting Hydrological Response, Carbon Balance and Emissions from Natural Mires in Arctic to Temperate Zone Transect in Abrupt Climate Change.
So before we start, maybe am I heard? Is everything okay? Okay. So hello, I'm really proud to be here, and it's a great opportunity for me to share the results of our research and also the description of the project itself. I'm not sure how to switch on the presentation, but before we do it, I should also relate to the other information provided today. So if you recall, there was a second round of Greek projects approval, and my project was one among those 7 who got funded in the second phase. So this means that we applied for the project in 2019 and we got it funded in 2021. And for some people, 2 years is nothing, but you possibly recall what happened during these 2 years. And then we also had these issues related to invasion of Russia to Ukraine. And our research sites are located also in Norway. Some of them originally were planned to be close by to the border, and we were forced to move them away from the border, but we managed to do it, and I'm quite happy to show you what we ended up with. So first, I should say great thank you to Ms. Barbara Świątkowska for helping us to get through all of the meanders of these things, because honestly everything changed, and I was really happy to see from the other presenters that not only our project was that much specific in terms of changing things, because some people started work somewhere else, we needed to switch partners, but at the end of the day we have our goal, only the path is a little bit different, but everything works. So Fourth, forecasting hydrological response, carbon balance, and emissions from different types of mires. So I will talk about the rationale of the project, about the force itself, and some preliminary results, and indicator table, which I hope will be admired by both the funding authorities, so Norwegian Research Fund, and also National Science Center of the Republic of Poland. So you possibly... I mean, it's the first time in my life that I'm talking after the lunch break, because normally I'm placed before the lunch break and all the people are struggling just to leave my presentation. So now you're well, and I can start my academic lecture with wetlands. The former session was very interesting because the landscape were spectacular. So you remember this Svalbard stuff, and wetlands are boring. So in fact, everything is flat in general, and there are some plants there, some water, everything works slow. So So in general, some of you might consider wetlands not that much interesting. But in fact, this is the third project funded by Norwegian Research Fund, in our case, in my case in particular, that are dealing with wetlands. We started, so my whole academic career was built up on this Norwegian research project. So this is the third one. And although wetlands divide themselves into saltwater and freshwater ones, we are dealing with only a little part of wetlands, which are called mires, which are living peatlands. So these are the wetlands which accumulate peat. And for those of you who've heard about peat, you already know that peatlands are spectacular, because although they cover only, let's say, 3% of the land area, they store a quarter of global soil carbon, twice as much as the world's forest. So if you imagine, if you look at Polish forests, for instance, they are proud of being a carbon sink, and in fact our wetlands should be considered more important because they store just seemingly more carbon. And then with peatlands, you should also remember that most of them are drained. So in Europe we only think that maybe 5% remained in the natural status. All of them were degraded. I mean, at that time, it was not degradation, it was land reclamation. They improved peatlands for agriculture. Nowadays, they are one of the main sources of emissions of greenhouse gases, those drained peatlands. So 95% of them are degraded. And only those who are restored, they can act as carbon sinks. So that's why our ultimate goal as a society, and also as we discussed it with our friends from the other countries, especially Norway, we know that there are considerable efforts put into increasing quality of peatlands. We don't understand some of them yet, because they change. They change because of climatic change, and this change is not linear. So this means that we can have peatlands in different geographic setups, and they will be vulnerable to different hydrological processes. The most important thing about our project is that when you talk about wetlands, it is normally people who are dealing with biota and biodiversity who are doing the research on wetlands. And this hydrological part has been omitted for most of the time in the history. Nowadays, since 1990s, we start to re-establish wetland hydrology again, to have a closer look at what happens there, especially when it comes to groundwater flow, evapotranspiration, and the other processes that are happening around the world. So here you can see some of our research sites. Some of them are quite well known. This is the Arctic Circle. So you see more or less what is the distribution. So this is a nice link between the Arctic research that have been presented before and this climatic research that is being presented just now. So we are looking at different elements starting from the permafrost changes, catchment areas, groundwater flow, duration of groundwater flow, origin of water, and content of carbon dioxide in groundwater, which is also a very important element. There is a bunch of hypotheses in our project. I don't want to get through all of them, but some of them are really interesting in terms of the fact that mires or peatlands are changing themselves. So they change from being fed with groundwater, which is rich in minerals, into the ones that are fed with rainwater, which comes from rain or from snowmelt. And this is related to ongoing processes of climatic change and the weather. In some places, the changes are not that significant, but in some other places, the changes are drastic. So peatlands that used to be formed in some places where water circulation were very local, now they start to be open to the landscape around, meaning that some new water can inflow there, bringing some nutrients, bringing some carbon dioxide, bringing completely new processes around. So we try to have a look at those processes together with checking how much greenhouse gases are emitted from those peatlands and how much carbon can be stored in there. What is also interesting in our case, and this is also a direct link to the other projects presented today, is the emission of carbon dioxide and greenhouse gases from open water, which was not that much tackled in peatlands yet. I mean, people are doing a lot of things when you talk about emitting of carbon dioxide. A lot of people measure that, and many things were already told. But when you look at the peatland itself, and when you know that it is evolving from hydrological perspective, so there are some water courses, open water there, no one before tried to account for the total balance of carbon in these systems. We try to do it by linking hydrology, ecology, and the other elements. So we have a bunch of research questions as well that will be reformulated into research papers, we hope, soon. The cooperation is very broad, and I consider myself a PI of the project, although I cannot speak for all of the guys because they are really specialized in different things. I'm wetland hydrologist, and I just know that things happen, and some of our colleagues from Institute of Geophysics, Technical University of Warsaw, University of Warsaw, NINA, and NTNU are helping us with finding answers to our questions. We have two associated institutions, two of the most important stakeholders when it comes to wetland management in Poland, which is Biebrze National Park, the biggest wetland area, and Milio Directorate, which is environmental directorate managing most of peatlands we do our research at in Norway. So these are the groups of peatlands we are doing our research at. So we start from the very north with Palsa, Myers, the ones which have ice core inside, and we get slowly through the south, through oceanic, through continental peatlands of Norway, to end up with the largest fens in Europe in Rospuda and the Biebrze Valley. So we have a gradient from north to south. Of course, the reviewers are always saying that we should have more sites, but if we have 10 sites, and they would say we still should have more, 20 would not be plenty. So we still struggle a bit with the number of research sites, but at least our initial results are very tempting, and we hope to formulate new hypotheses at the end of the project. So we don't have many results yet, but we are continuously developing new research devices that are already functioning in the field. So we spent in Norway this year already a lot of time. On Monday, we are again going to Norway to do our research in some wetlands. But comparing to some of the research devices you showed, our research is still, let's say, at the beginning of some methods, because although the emission factors can be calculated on the basis of very sophisticated research of eddy covariance or some chamber methods, the biggest problem of that is that it is very limited in space. So this means that you have one point or few chambers. We try to do it statistically significant, meaning that we try to install a lot of devices in one place just to see whether the internal variability is not covering the spatial variability of the process we are measuring. So we spend a lot of time constructing our own research devices, especially the ones for collecting data from the lakes, which are placed in those little peatlands we are doing our research at. I'm sorry, it should not be there, that picture. So we try to put this research devices in as many places as possible, and our field research is driven by the Sudoku, as I tried already to explain here before, because we must exchange the batteries, and it means that if some people are going there far north to do some vegetation ecology research, they take batteries to exchange it, so we must fit into the schedule of flights and all the other stuff. But so far we've been really successful, and the next field year is also very promising for us. Some research devices are quite new, and they used to be conceptual. As you can see here, it evolved from the concept to the real measurement device, but no one did it before. I mean, no one measured what are the concentrations of greenhouse gases at different levels of the peatland at once. And it's not that easy to find out how those research devices might function. This already works. We have some of them constructed already, so we hope to have some good results the next year. As you possibly remember, I said before that it's very important to be able to measure these processes in a broad geographical range. So it's not like we have one point and we do the measurements. That's why we need to be a National Science Center. We need to be cost effective, and we are cost effective. We try to do it as good as we can and as cheap as it is possible. And we have a great fun doing our field research. So it's not only about sampling. You can see here in the top right, that's a sample of peat with ice inside. So this shows clearly that we are there in this Palsa region, and we found those palsas, which are unfortunately degrading because of the climatic change. So we have a spectacular research site, especially the one there far up north. This is myself standing here with the Sami flag, and this is a peat sample that we collected to the laboratory. I mean, it's not... I mean, it's fun, but it's not happy fun. This means that we are documenting the environment which is degrading. Although we see that it looks nice and there is still water on the top and it looks nice and green, it is all the consequence of a climatic change and global warming, especially visible in this Palsa region in northern Finnmark, when we see that these palsas are just defreezing and the elevation of Palsa is getting down. So no one did this type of research before. We try, as I said, we try to analyze what is the origin of water, where does the water come from. And our preliminary results show that we have been quite lucky, and we were right with our initial hypothesis of the project. So it means that although we are doing our research in different sites, these are different sites, as Overflora close by to Trondheim, and the other one is Suosiavri in Finnmark, we see that different types of peatlands that evolve at one spot, they are completely different in terms of groundwater, which is bringing their carbon dioxide, completely different when it comes to emissions, completely different even from open water, as you can see here on this graph. So the mire itself and open water. So we hope that with our modeling tools, we will be able to provide new hypotheses, which are for wetland hydrology, in my opinion, groundbreaking. And I hope to show you the next time nice papers already published, like we have seen before in the presentation, that you already show papers. Bear in mind that we started a bit later, but we are bloody efficient in getting some new ideas. To prove it, that's just the end, and this is a tribute to Alexandra, who talked about the Norwegian National Science Center. In our consortium, we already marked that one of the measures of our success will be to apply for a new project in this consortium. So we applied for the new project, and we already got it from Norwegian Science Center. So it's really nice to know that this wetland research is really ongoing, and that quite huge budgets are allocated into the wetland research. So that's the one. Peatways, as you can see here, there should be some 12 million crowns. So that's a lot. And a very nice consortium, again, build up on our NCN cooperation and on our ideas that we already developed. The most beautiful picture I found to compare with the other pictures from Svalbard, still nice. So may the force be with us. Thank you.
Are there any questions? Thank you very much. It was Mateusz Grigoruk from Warsaw University of Life Science. Thank you very much for a very interesting presentation. And we will go exactly to the second panel provided by Sara Benelli from University of Gdańsk. Presentation on the project entitled Benefic Coastal Buffers Against Climatic and Eutrophication Extremes.
Good afternoon, everybody. Thank you very much for the invitation. I'm happy to talk about my project that has the title Benefic Coastal Buffers Against Climatic and Eutrophication Extremes. First of all, a few words about me. I'm Italian. I did my bachelor and master degrees at the University of Parma in Italy, and my PhD in ecology at the University of Ferrara. During my PhD, I collaborated with different research groups, one at the University of Klaipėda in Lithuania, and with scientists of the National Research Institute in Bordeaux, France. After my PhD, I did 3 years of research fellow at the University of Parma with, under the supervision of Professor Marco Bartoli in the group of aquatic ecology. 1 year ago, I started a buffer project with a group of Professor Janas at the University of Gdańsk Institute of Oceanography. The choice of this host institution was made for the expertise and know-how of this research group on the species diversity of benthic communities along spatial and temporal gradients of the Gulf of Gdansk. We met for the first time in 2015 during a European project on the Baltic Sea, in which I was involved from the Lithuanian part when I was working with them. And my expertise are from mainly in ecology and in biogeochemistry. The most important aspect of biogeochemistry is the study of chemical cycles, and like phosphorus and nitrogen, and the way they interact with the living things and the environment. So the transformation and the movement of the chemical compounds in an ecosystem is called biogeochemical cycling. So my PhD was mainly on investigation of the effects of macrofauna, macrophyte, and bacteria, and on to study the emerging properties associated to their interaction. And in shallow benthic systems, there are hotspots that are small areas and hot moments that there are brief periods in which these biogeochemical processes can be enhanced or inhibited by the presence of organisms. More recently, my research focused on the on the benthic system of the coastal zones affected by eutrophication and climate change. Everybody knows how important are estuaries and coastal zones. They are transitional zones at the interface between the fresh and the marine environments. They host a large amount of energy and matter fluxes, and they can receive a large amount of nutrients. One of the factors that affects the estuary in the coastal zones is eutrophication. Eutrophication as nutrient enrichment means elevated or increased trends of inputs from the land, from the atmosphere, and from the adjacent seas. It's a natural occurring process in most of the coastal zone. However, the presence of human activities in this zone is dramatically increase this process. Besides eutrophication, there is climate change. In particular, in the northern latitude, climate change is expected to affect patterns of ice formation and melting, precipitation, and temperature regimes, and may offset estuarine function via, for example, the floods, storms, heat waves, or prolonged dry periods. And climatic extremes often resulting in extreme hydrological conditions, as you can see from the pictures, and that means that there is impact on the functioning of these systems. For example, here just an example of within the nitrogen cycling. During high rainfall, there could be the residence time decrease, and so process like denitrification that remove nitrogen from the systems can be reduced. And at the same on the other hand, in presence of a prolonged dry period, there is a increase of recycling of nutrients within the system. That means, for example, higher blooms of algae in the system. The Baltic Sea, everybody knows that has one of the worst situations in this sense. More than 97% of the Baltic Sea suffer from eutrophication. And however, there is a macro-regional approach that help to face this problem. And this macro-regional approach consists of the collaboration and the project between all the countries that face the Baltic Sea that can give to a larger scale what can be the policies or the solution for these problems. And for a person, for a scientist like me that is coming from southern Europe, this opportunity of this call and of this project to work with people within this area and within this this research is a great opportunity. Also because we have the same problem in the southern Europe, but we don't have such a macro-regional approach, macro-regional collaboration between the countries. And so, going to more in detail in our project, the approach that was in the Buffer project is to analyze if and how sedimentary buffer capacity of the European coastal environments can be affected by the synergic eutrophication and climate change. The buffer capacity is the capacity of sediment to mineralize organic matter inputs, to avoid accumulation of black carbon, sulfides, and methane, loss of ecosystem services, for example, denitrification, phosphorus retention, and the loss of benthic biodiversity. I tried to explain with an example what we mean for buffer capacity. Here represented sediment in the brown color and water column in the blue color. The sediment are oxygenated just as you can see from the light brown color. So sediment, most of the sediment is anoxic, it's without oxygen. One of the things that sediment do is that they process organic matter and carbon, they release nutrients, and they can produce or at the same time consume greenhouse gases. But in presence of, for example, fauna or plants, this zone that is more oxidized, that can act as buffer, can increase. So, for example, macrofauna can create these burrows deep into the sediment, and the buffer capacity of, in this case of the sediment, can increase. The same when there is, for example, plants that release oxygen via the roots, and they can do exactly increasing the buffer capacity. Buffer consists of 8 work packages that are strictly related, and that mainly we want to evaluate the trophic status of the sediments and to understand how the capacity, the biogeochemical capacity of the sediment to retain phosphorus, to dissipate nitrogen, process silica, and as last, we want to understand the contribution of macrofauna or plants that are present in this sediment on the buffer capacity. And the study area, the main study area is the Gulf of Gdansk, and which is characterized by different sedimentary environments. But we added also 2 additional study sites. One is in Italy, the Sacca di Goro, thanks to the collaboration with Professor Bartoli of the University of Parma, and the other one are the fjords in Norway, thanks to the collaboration with Professor Raoul Primicero of the Arctic University of Norway. This collaboration gave us the opportunity to understand or to investigate this buffer capacity along a wide latitudinal gradient. For the moment, in this year, we did most of the experimental activity. Here some picture of our cruises during in the Gulf of Gdańsk, where we sample different sedimentary environments. Sediment were then incubated under dark and light conditions and under different oxygen saturation level to mimic the different condition in the field. For this year, we did most of the sampling activity, the 3 seasons in both Poland and in Italy. And for the next year, we plan to go to Norway for the same experimental activities. Some of the picture of the amazing team that we have, during this year, we went through these different places. And if you want to follow our project, you are welcome to our website and the Institute website and some contacts. So thank you for the attention.
Thank you very much. Are there any questions?
Thank you.
This was Sara Benelli from University of Gdańsk, and now we are heading, well, exactly to our last presentation, because the last one planned in the agenda, Artur Marchewka, unfortunately didn't manage to join us. So now I welcome Barbara Jancewicz from University of Warsaw with the presentation entitled Embodying Climate Change, Transdisciplinary Research on Urban Overheating.
Yeah, oh, great. So welcome everyone. My name is Barbara Jancewicz and I'm here to present to you our project Embodying Climate Change, which is led by Dr. Zofia Boni from University of Adam Mickiewicz, and I'm the project partner from University of Warsaw. So my presentation is going to be a bit different from the previous one because our project focuses much more on people. Our funding is, of course, from the IDEA Lab call, from the Norway grants. And as you could have seen in the morning, a lot of talk about climate change has beautiful pictures. And a lot of it is very, very abstract and far, far away. We know that climate change can have a lot of impacts. And we're more focused on those that are, well, very apparent and in front of our eyes. However, a lot of climate change results are also very close to us, very close to our bodies, but they are not so very much visible. And what we focus is heat. Because what is amazing is that heat can kill people, and it can kill it as effectively as a lot of storms and other disasters that we're facing. But it's a lot of times overlooked because it's invisible. When you look at pictures of heat, we actually see fires, we see, I don't know, ice melting. But it's very hard to show in a picture that someone is suffering from overheating. So this is what we wanted to focus on. In climate science, we can see that the natural scientists are much more represented and very little funding is going to the social sciences. And we wanted to change that because if we want to tackle climate change and adapt to its results, we actually need to understand how people are causing it and how people are adapting to the results of it. Because we need to adapt, because it's not going to go back. So, what do we focus on even more? Is we focus on the cities, because a lot of people are living in the cities, and probably more and more people are going to live there, because there is urbanization going on. And also in the cities, the temperatures are even higher than in the surrounding areas due to heat island effect. And another focus of our results is the older adults. Because again, this is something that gets overlooked a lot. And hopefully we all are going to be old one day because we're going to live very, very long. And Europe is getting older. So we will have more and more of old people on our hands very, very soon. We conducted our research in 2 places that were very different, both inland cities, capitals of their countries, and both cities have different experiences with heat. Madrid, well, traditionally has a lot of heat. They're coping with it in their own traditional ways. And Warsaw, which, well, doesn't have that much experience with it. And a lot of people are not prepared for increasing temperatures. So, how are we doing the research? We have very, well, precise focus. So we're trying to go really broad with the way we're looking at it. We have multiple ways we approach the same topic. And as you can see, we have a lot of methods we're using, but we're all focusing in the middle on the people that actually are the center of our studies. First of all, we started from ethnography. This is our main core. We have 3 ethnographers on our team. And what you can see here is actually a snapshot from a movie we're going to release next month. And, well, you can follow our website to find out more about it when it comes out. By now, you can see also movies from our workshops, which we already conducted with the elderly people. So, for those of you that are not, well, doesn't know much about ethnography, it is a very intimate study of people and how they react to things. These are not only interviews, but we have researchers that get to know people they're studying. They meet with them throughout the whole summer, bi-weekly, and they, well, spend time with them, observe them, talk to them. So a lot of times we would have people that would say, no, I'm perfectly fine, the heat isn't affecting me at all, but you can see that the person is perspiring a lot, that they're, well, walking a bit wobbly, or they have other signs of exhaustion. So we could also see the ways that they are dealing with it, not only those that they are telling us about, but also when we can see that the person drinks more or gets undressed or does some other things that make it easier for them to cope. So we get very intimate understanding of how people are relating to the heat, how are they dealing with it. And then we combine it with, well, something more objective, which is sensors. We actually, after getting to know our participants in Warsaw and Madrid, we equipped them with temperature and humidity sensors that they carry with them all day long. And we see how are the temperatures they are actually experiencing related to the temperatures that are recorded in the cities. And we can see they are different. And typically those people are experiencing higher temperatures than those recorded in the temperature stations and meteorological stations throughout both cities. Also, when we cooperate, like within our team, the physicists and the ethnographers, we can make sense of a lot of data that normally would get tossed out because they are abnormal. But then when we talk to each other, we find out that the participant was grilling in the middle of a summer, or that someone went to a supermarket to get cool, so the temperature suddenly dropped. So a lot of those anomalous recordings, we can actually explain and understand how did they happen about, and we don't have to throw them out. We can explain them and use them in our studies. Another part is we're going a bit higher. Like from this intimate understanding of single people, we went to understanding groups of people in our focus groups interviews, when we talked with the elderly to find out what they think in a group, how they talk to each other about heat, about dealing with it, and how do they like it. Because a lot of times in Warsaw, if you ask someone about heat, they will talk about the summer and the holidays and resting near the seaside. Only when the heat is in the city, well, not in Gdańsk, but in an inland city, it becomes a problem. And another thing is our survey. We conducted a survey in Warsaw and Madrid. Actually, I'm pretty excited because we're just, well, we're getting the results right now. We finished data gathering, and now we're making sure everything is the way it's supposed to be. As you could see, because we are cooperating with physicists, we also gathered temperature measurements also during the interviews. So we will, again, not only have people's opinions and the reviews on things, but also we'll have some concrete measurement that we can, well, compare and that can complement each other. Oh, and now another thing that we are doing is policy analysis and reports to make sure that, well, what we're doing actually can have an impact that actually relates to the situation and to things that are possible. We checked what is happening both at the EU level, the national level, and the city level, because it turns out that depending where you are, heat wave and heat wave alarms are created differently, defined differently, and at different points of time and temperature. Also, we had reports made for us by a medical doctor that explained to us what are the problems with heat and what are the best ways to deal with them, and with architects that told us that each city has their characteristics that impact the way people feel heat. The architecture is pretty important because it turns out that even in the same city, even in the same district, two people can experience vastly different temperatures depending on their exact location, their building, and their nearest surroundings. So our physicists, environmental scientists, they prepared a citywide heat mapping that they are trying to predict both, well, understand what kind of temperatures we're having today in different parts of the city and what kind of temperatures we can expect in the future. And it turns out that it actually needed a development of a whole new model, how to make it more detailed. Not to have just like one temperature for the whole city or one temperature for the whole district, but to have it more detailed to account for those differences that are very important for the people that are actually living in those areas. And finally, our last part is modeling. We have climate modeling, which probably a lot of you are well acquainted with, but also demographic and epidemiological modeling, because we want to know, we already know, or at least hope to know, what kind of temperatures we can expect. Now we want to know what kind of people will experience those temperatures and what kind of safeguards we need to have in place to protect them. So we're wondering in which areas of the cities there are going to be more or less vulnerable people, more or less and elderly and poor. And well, as you noticed, I talked about a lot of research and it needs a lot of people on the team. And each of this person has different qualifications. And well, most of us are in different disciplines, which actually is possible only because we got this Idea Lab grant. I can tell you from experience because I was also participating in another grant application that didn't happen. And we tried to find a different funding source, and we didn't. We had to split it along discipline lines. So this is this one situation when we can have those multiple disciplines and multiple people that focus on one goal. And I think that makes our research much, much better. Well, we can say that, well, we are focusing on the experiences of heat exposure and, well, filling the gaps of looking at things that were overlooked. But also, I think that a huge advantage of our project is that we talk to each other and we find out how other disciplines are seeing things. So we can not only incorporate it in a way we talk within our discipline, but also generate something bigger that talks across disciplines, that we can just have results that matter and that are understandable to everyone. So thank you very much. And please follow us on our website. I hope the movie will be out soon. And I've seen the glimpses and it's awesome. Thank you.
Are there any questions to this lecture? Ladies and gentlemen, this was the last presentation that we have prepared for today's conference. Through all day, we heard 8 very interesting presentations and lectures with very interesting research results. Thank you everyone for participation. Thank you also people that join us online. Thank you also for the lecturers that shared their projects, details about their projects. But I find in every presentation a little bit of passion of what you are doing. And of course, I'm keeping fingers crossed for further researchers in your projects. And I hope that all of them will be very successful. Thank you. A great thanks for the National Science Center in Poland for organizing this kind of conference. I hope that it is not the last one that we can have in very nice view here in Oliwia Business Center in Gdańsk. Thank you everyone, and let's hear each other again.